All right. Well, happy Wednesday. We're doing our last session on arrays and vectors, right? Hopefully the lab went relatively well. Again, the idea is we're just letting people build the maze any way they want to. Just let them tell us what size. We'll make the 2D vector of that size and let them start throwing characters in there. They've got to have a start. They've got to have an end. And anything else they want to put in there, usually it's walls, right? Go for it. They can put characters in. So it's a 2D vector of characters. Kind of like we did with our tic-tac-toe game, which I did finish in lab. I finished the last two pieces because it was fun. This make move portion here. I haven't updated it yet. Right? That's where we left off. We're going to print the board. We're going to get a row and index input from the user. We're going to make sure it was a valid row and index input. Right? It's got to be within 0, 1, and 2. And then that space has to be open. You can't mark on top of somebody. And then we'll actually go and mark the board. Right? So we go ahead and pull that change here. 50. So now it says, hey, I've got things to pull because I've changed the repository in the cloud. My computer doesn't have that change yet because I did it from the lab computer. So I do a pull, it'll go and update my file. Visual Studio goes and updates it now. Super happy. So we made print board function. I'm royal apparently. I do this all the time and it drives me crazy. So print board, you could do loops and things, but I wanted it to print out a specific way to look pretty with like the lines. So I didn't bother with a loop because I printed out the space, a pipe character, the space, a pipe character, the space, and then the horizontal line, and then row one with all the pipes, and then another line, and then the third row with the pipes. That's all. So we print the board, and then we ask the person to input something. Say, this is the current player's turn. Enter your own column index. We'll get their own column index. And then if it's invalid, I keep on asking, right? The sort of validation loop. So if it's less than 0 or more than 2 for the row index, or if the column index is less than 0 or more than 2, or that spot is not blank. Now you gotta be a little careful when you do these because if you check for this one first, you could crash, right? Trying to get an index that doesn't exist will crash your program, right? Vectors don't let you do that. So this has to come after these checks here because C++ does something kind of smart here. It realizes that we're ORing all these things together. And these are specifically known as short circuit ORs, so that as soon as it finds the first thing is true, it stops looking. It says that's a waste of my computer time to check these other things because once I have one true in an OR, the whole thing's true. So it will short circuit. It says, okay, if this is true, stop. The whole thing is true. Let's go into the code, right? So it's only evaluating them as it finds falses. Right. So if this one is false, then it'll check this one. If that one's false, then it'll check this one. If that one's false, it'll check this one. On and on and on. Right. It does them in order because it's going to short circuit. It wants to save some time. That's a optimization. Right. So make sure you do this one last. Is all. Okay. And then we tell them, hey, that was invalid. Try again. And I just keep them in that loop until I get something that is valid. And then we mark it by setting the value to the current player. And that's what our loop did. Right. Uh, we get a move, next player, get a move, next player. So while the game's not over, we make a move and we go to the next player. Make a move, we go to the next player. Right? I might move print board. I don't really love that that's part of make move, but maybe that's useful to like reprint the board every time to tell them what it is. So I think it's okay. And again, it'll do the same thing whether or not it's inside of make move or whether or not I put it right before I call make move. It'll still print the board. So I've got a function for it. Doesn't really matter where I put it. It's more of just a preference at that point. But then we should be able to do tic-tac-toe, right? Because all the other stuff we wrote should be done. We looked at is game tied. So the two different ways for game tied, right? The enhanced for loop or this read-only for loop, right? Getting out each row is a vector of characters. Getting out each character from within that row, I can check what those characters are. So this is probably the easy way to type it. Or you can use the index notation, right? And again, you always want to go off of size. So size is important because for tic-tac-toe, we know it's 3. But like with that maze example, they could have entered 50 by 50. They could have entered 3 by 3. We don't know what it is. We just set the vector to that size, right? So use the vector size for the number of rows, right? Because it's not actually rows and columns. This is just how we imagine it, right? So this is how many subvectors are there within the big vector, right? Because it's a vector of vectors. So we're saying how many vectors of characters do we have inside of our vector of vectors? That's the size. That's and what we essentially call row, right? Then to see how many columns are within that row, how many items are within that subvector, you want to go off the size of that particular row because these don't have to be square, right? I could have 3 rows and each row could have 50 columns. Sure, it's perfectly fine, right? So that inner vector then has a size. That's what we want to go off of to make sure we can make these things rectangular or even jagged at that point, right? The first vector might have 5, the second vector row might have 12, the third vector row might have 2, the fourth vector row could have 50. Like nothing says they have to be even. We made them even because we told them to give us a rectangle, but nothing makes vectors be even like that. So you always want to go off of the correct size, which one you're looking at, and we're doing this one. So, but again, if you just use the enhanced for loop, it'll do it for you. We don't need the row and column indexes because we're not changing anything. If we wanted to change something in the board, set a value, then we have to use the index notation, right? You can't set anything here with these read-only values. That's all, right? Right, so let's try. Let's see, I think we can play tic-tac-toe. I forgot to put a loop in to let me keep playing here. Oop, I don't need my breakpoint. So continue. There we go. All right, it's X's turn. Where do you want to go? 0, 0. Okay, so I'll go in the center. I'll go 1, 1. 2, 0. All right, so I have to go to row 1, column 0 to block you. 1, 2. You block me. And now you can't win. Sad. So I need to make sure that I'm going to stop you from winning or make you go somewhere. I like the corner, so I'll go 0, 2. That stops 2 different 3 in a row. The only one you have left is the bottom row. 3, 3. Invalid location. Or 0, 1, and 2 based. 2, 2. All right, so I have to stop you. So I'm in row 2, column 1. 1, 2. 0, 2. 0, 1. You mean? 0, 1. And we get a game over. Cat's game. Very exciting. That was tic-tac-toe. So that was a two-dimensional vector. Now we looked a little bit at how we could pass things to functions, right? This sum of values, you could pass a array to a function, sum of values. Now the fun thing though with arrays is, where did I do that? We'll just put it at the top, right? Because why not? If I wanted to ask the user, how many numbers do you want to enter? And then maybe I'll have an int for size of numbers. And then cn on size of numbers. Size of numbers. If I wanted to make an integer array called, this is numbers to enter, size of numbers, I get an error. It says expression must have a constant value. So when you use arrays, you can't use a variable because the compiler has to know what the value is at compile time. You can't enter it while the program's running because it's going to go and plan this all out and say, okay, it will need this much space in memory here. And if it's something the user enters, it doesn't know how much space in memory it needs because it's completely fixed with arrays. So you can't even do this at all. This is real sad. So one option, and I don't recommend this, but you might see people do it here, is they might size this to something ridiculous, right? It'd be like 100, and then if you entered something less than 100, I'm only going to fill in the first X number of these things, so I'm going to waste a bunch of space. You could do that, right? So I could have room for 100, right? Oh, oversize, leave room for numbers. You can do that. But now, like when you're trying to sum your vector or sum your array, you could and just tell them go less indexes. Like this, you entered 15, so we could give them 15, and we can only sum the first 15 values and just ignore the 85 garbage values. That's an option, right? Again, I don't recommend it, but you might see people do stuff like that because otherwise you don't use arrays. And this is why vectors are just so much nicer, right? Vectors are awesome. Right? You just push back, just add as many as you want, right? Um, so this idea of setting the vectors, we gave it a given size and sized it, so we knew how many there were. If you didn't want to use the at notation, right, you could use the pushback, right? So we could do a vector of char. We'll call this, I don't know, what do we, our maze or something, right? And then just do these for loops. So for int row is 0, row is less than the, I don't know what we call it, the number of numbers to enter. Sure, why not? Row plus plus. Did I do the wrong thing? Oh, no, size of numbers. Sorry, that's fine. Sorry, that error was actually really interesting. When it says it's less than, operand types are incompatible, int and int star. Int star doesn't mean a whole lot to us yet. We haven't got to that chapter, right? Essentially an array right now, but it doesn't look like an array. There's no square brace notation here. So if you see that, probably because you gave it an array. Right? That was all. That's what that one was. Make sure I use an actual integer. Okay. So the first thing we'd have to do then, we take our maze and we would push back a vector of type char. Right? So add an empty row here. I didn't pre-size one. I didn't have one, so I don't have anything to set. I can't use the at notation because nothing's there. So I'm going to go and push back one. Then I need to go and loop for in column is 0. Right? Steal that. Less than size of numbers. Now it's my maze at the row. It will give me the thing I just added here. Here, then I can push back. Push back. Now I just push back a character because this one is single character. Right, so this creates it's an empty row, and this sets each column in the empty row to blank. Right, it adds it. It's not really set. It adds. I guess adds each column in the empty row as blank. That's probably a better notation, right? So this one we're setting, this one we're adding. So this would be slightly faster because we've pre-sized it. Again, for 3 by 3, nobody cares. If you're doing like 1,000 by 1,000, it actually is a little bit slow when you start pushing back because it has to find the space to do these things. And we'll talk about that next semester in 200 and looking at the space it needs and how it does those sorts of things. And it's really fun if you like that sort of stuff. Okay. Other people find it really boring, but that's okay. Right. So either notation here then is going to work for us, right? Whichever one you picked for your maze should be fine, right? Either add an empty and add all of them, or set them and then go set them. Right? Both should work for us. Or the easiest one, right? If you know what they are, you can just hard code it in. But obviously, we couldn't do this with a maze. Right? We couldn't hard code a given size maze. We didn't know what the size was. Right? So this one wasn't an option. This was easy for tic-tac-toe because it was here. Right? Anything beyond this, like this was about the same number of lines of code, perfectly fine. If you're getting bigger than this, I would just do the loops. It's probably a little easier. Right? So you guys familiar with the game Connect 4? Do we go through how you can win or lose a Connect 4 and go to the website? We didn't do that. So there's a website. The first player in Connect 4 is guaranteed to win if they know what they're doing. Every time. It's an unfair game. So if you know what you're doing, you will always win. Unlike tic-tac-toe, where if you know what you're doing, you'll never lose. This one you'll always win. And the second player is just screwed. There's no way to stop the first player from winning. Right? So that one's not as fun. But do you think we could turn this sort of idea, this sort of logic, into Connect 4? It's basically the same loop, right? If the game's not over, someone make a move. Change from X's to O's or red to green, yellow or whatever colors you want. Right? The loop is literally identical. Right? That's the interesting thing. Like it's the exact same sequence for the game. Each players alternate until the game's over, regardless of tic-tac-toe or Connect 4. What's different is the board right? It's a bigger board. It's 7 columns by 6 rows, or 6 rows by 7 columns. That's probably more proper, right? So we'd have a different size board, and then our loops are different, right? Make move is different, right? All you give it is a column, and it has to drop down to the lowest open spot. It's a little bit different. We could figure that out, right? Printing, I would just use a loop here because I mean we could print out this sort of grid if you wanted, but this gets a little awkward. Or we could find other options for doing it. You got lots of choices, but printing's somewhat similar. Is the game over? Is whether or not it's tied or 4 in a row. Right, little modification, but same idea. Either the game's been tied or it's 4 in a row. And if the game is tied, same idea. If we find a blank, it's not tied. If we don't find a blank, it is tied. Right? Literally the same function here for is tied. What's different is the 3 in a row or 4 in rows, right? 4 in a row horizontally is a little bit trickier because when you look at a board, there are 7 columns in your 6 rows. So we have to look for every row, look for every set of 4, right? There's a 4, and there's a 4, there's a 4, and there's a 4. There's four options, right? So from 0 to 3, from 1 to 4, from 2 to 5, and from 3 to 6. Right? Those are your 4 in a row options across your columns, right? So should I draw a picture? Pictures are fun. I like pictures. Right, so if we have our board here, right, and we have 7 columns. So there's 1, 2, 3, 4, 5, 6, 7. And we have 6 rows. 1, 2, 3, 4, 5, and 6. It's not the best picture, but it'll do, right? So this is row 0, row 1, row 2, row 3, row 4, row 5, and column 0, column 1, column 2, column 3, column 4, column 5, and column 6. I should have brought my tablet. It's so much easier. Right, so if we're looking in each row, right, there's 4 in a row from 0 to 3. There's 4 in a row from 1 to 4. There's 4 in a row from 2 to 5, and 4 in a row from 3 to 6. So we just need a loop that goes from 0 to 3, looking for 4 in a row for horizontal wins, right? Same idea? Do you want to build out Connect 4? No? Okay, we don't have to. Right? Vertical, same idea. We have 3 different sets, right? Starting at this column, right? For every row, then we'll look at from 0 to 3, or from 1 to 4, or from 2 to 6. So a loop within a loop. For every row, or sorry, for every column, look at these 4 rows. That was not so bad. Now, this one, I would say the diagonals we should split up, right? We didn't split up the diagonals. We just did it all together, right? It was either this diagonal or this diagonal. Perfectly fine. This one gets trickier. So you have a diagonal up and you have a diagonal down. Right? We can do that. So same idea, right? To figure out a diagonal, you're either going to start at the top at column 0 and go down. So look at 0, 1, and 2. Or you're going to start at the bottom, look at 5, 4, and 3 going up. Because you have to have 4 columns and 4 rows. Right? So your grid here then is pretty easy. You're going to look at these 12 squares for diagonal down, those directions, right? Or you're going to look at these 12 squares for diagonal ups. Right? So any one of these starting 12 squares can have a diagonal up, and any one of these starting squares can have a diagonal down. So it's a loop within a loop, and we look at either add a row and add a column to go down, sorry, this direction, right? Add a row, add a column to go down, or subtract a row to go up and add a column. That's all it is. Right? We just break it apart into smaller pieces, and now we have a new game. Right? Not too much different here for this one, for Connect 4. That was kind of fun. So you can play with 2-dimensional vectors, use that row index, use the column index notation, at notation, and it works out pretty well, right? The enhanced for loops are going to be harder for that, right? Where we just try the read-only thing. Like for this one, for tied, it's fine. But it's really hard to do like add a row, add a column if you're just getting individual characters out, right? So we're not going to do these loops very often. We're always going to use the row index and the column index notation, right? Except for is tied. Where we just looked at every single one. That's all. It's harder to restrict if you don't have the indexes, right? So instead of our row index is less than board size, we check, hey, row index is less than 4 or 3, right? Because we want row 0, 1, and 2. Or we could start at row 5 and go 5, 4, and 3 as long as we're greater than 2, right? Either way is going to work for us. We can just do the loops in different directions. All right, let's see. Did we get through arrays and vectors? Two-dimensional arrays. So you can do the same with the array notation. So this is a little easier to write with this array notation because you don't have to do all the adding, you don't have to do all the pushback stuff, you don't have to do all the setting. So two-dimensional arrays are pretty nice just for being able to get at them. So if we want a 2D array of something, where'd my main go here? Main, there we go. So if I wanted an integer array of, oh, sorry, other comes after here. So int, what do I want to call this one? How about our checkers board? Size 8 and size 8. I'm sorry, not int, char. It should be a character array of checkers board, size 8 and 8. Right? This creates the checkers board of size 8 and 8. Now I can go through and loop, right? And go and set the size. Again, it's probably better to have a constant here, like constant int board size equals 8. This is probably a little nicer here. Use board size and board size. Right? And then for int row index 0, row index is less than the board size, row index plus plus. And I'll loop through for columns, right? For int column index is 0, column index is less than board size, column index plus plus. I can go to my checkers board, index of row index, index of column index, and assign it maybe a space to start, right? There's no checker on here to start. We want every other checker for 3 rows to set up the checkers board with white and black checkers. We could do that, right? We'll set them all to space to start, and then we'll go add the individual checkers, right? After we do that, then we're going to loop through. So I only want 3 rows worth, right, for the white checkers. We'll do 3 rows, and then I want every other column alternating. This is where it gets kind of messy here. So this next loop here to set up checkers, right? The first row you get indexes 0, 2, 4, and 6. And the next row you get indexes 1, 3, 5, and 7 because they alternate for checkers. So we can do that. So we're going to go for column index. Now we want to start at, how about row index? And this is where you can just do some silly arithmetic. We say, hey, mod 2. So whatever the row index is, we'll just go mod 2. So if it's even, we'll start at 0. If it's odd, we'll start at 1. Right? It's perfectly fine. And then we'll create column index instead of plus plus, we'll say plus equals 2. Let's add 2 columns every time because we're always going every other column when we add our pieces in here. And then instead of setting it to blank here, we'll set it maybe to W for a white checker. Right? We can do that. And then we repeat again here. So now we want to start at row, we want 5, 6, and 7, right? As long as we're less than 8 or board size. Doesn't matter too much here. Row index plus plus, same alternating here, right? If it's even, start at 0. If it's odd, go to every other, right? I think that's how it lines up with checkers. I'd have to look at a board now. Yeah, that's going to work, right? And then we'll set black checkers. And then we're done. Let's print the board. I think we even have a print board. Oh, we can't do this one. We didn't go for everything here, so that's fine. So we'll say for, this will be a character array, char array row, no, char row in the checkers board. No, I had it on the right side, didn't I? I did not have it on the right side. Goodness gracious. Character array, the row in the checkers board. Wow. It's not letting me do that. Am I going crazy? Board size? Called row? Huh. Expected a colon. Can't do an individual character though. Okay, char, yeah. So char array of board size. There we go. Okay. No. Wow. Doesn't even let me do the loops. Well, that's annoying. Well, let's just use the index ones then. Can we not do that? That's what the array. Enhanced for loop with multi-dimensional array. Okay. This gets really messy. It looks like we can do that. Um, that's fun. For auto row. Haha. Auto is a fun keyword. We haven't really looked at this yet. I think Zybooks talked about it way back when. No, it didn't talk about it at all. So auto is a little bit of a way of cheating. So instead of telling C++ that this is an integer, we say, hey, you figure it out. Whatever thing is on the right must be the type, right? So if we're assigning an integer to something, like you have auto some number equals 5, some number is an integer. When we hover over it, it knows it's an integer because C++ knows that 5 is an int. If I wanted to change this to 5.0, now we get this is a double. So autos are our way to cheat and say, hey, compiler, you figure it out. Because you must know what's on the right side, because we know what these right-hand side types are. Um, so what even type is this then? Char row. Oh, with a stupid star. That's obnoxious. I wouldn't recommend this. I would not recommend this one. Not recommended. Yeah. So I don't think this will work then. Auto column in row. Yeah, doesn't let us do that. So no good. After we take care of the pointers chapter, we can do this. We'll get there later. All right. So we just going to print out the board. So print row index to this one here, right? Instead of grabbing it here, we just want to see out it. Let's see out the character. At the end of every row, then, I want to see out an end line. Go down a line. So we're going to see if we've got the board set up right. That was all. So white, black, white, or white blank, white blank, white blank, and then two empty rows and all of our black pieces. Does that look right for a checkers board? I think that looks right for checkers. Pretty exciting. And we can play checkers. Now this one's like, while not game over, make move. Is that the same loop? While not game over, make move. Now the player's turn still flips back and forth. We don't have X's and O's, we have white and black. Sure. Slightly different chains there for white and black. Now, but making a valid move is much trickier in this game, right? Because you have to tell them what checker and where you're going with it. And then we have to see is it valid. Right? So figuring out if it's valid is a little tricky, right? Did you give me a checker? The first thing is it's valid. Or is it within range? And then did you give me one of your checkers? And then is the place you're going a valid move? Right? And valid moves are tricky because you're either moving into an empty space or jumping a piece. Right? So there's like two different ways that your move can be valid. So it's a little weird. But again, we could take a big problem and break it down into smaller problems, right? We won't actually do it here, but imagine if we wanted to figure out if checker moves is valid, right? Where is our is valid here? Excuse me. This one was our valid loop here. So I think I would break this up into different pieces, right? Get the row and column index. First thing we'd want to check, right? So if we were doing this make move for checkers, make checker move, given the char for the current player, given the vector of char, reference for the board, right? So we want to check for valid move first, right? So we have to get the row and column. And then the first thing we're going to do is make sure they're inbounds in the board. Make sure the piece is the current player's piece. So get row and column for piece to move, and then get the row and column for destination. Right? Make sure both are within. Make sure that the piece is the current player's piece, and then two things can happen, right? So either the destination is within range and empty, right? It's one jump away, one move away, and empty, or the destination jumps over an enemy checker, and is empty, right? So you're going two away, but there was an enemy within range, right? Either one of those is a valid checkers move, right? It's been a little while since I played checkers. It's not my favorite game. So my grandpa loved checkers. I preferred chess, probably because he beat me all the time. But my mom and brother would beat me at chess too, so I don't know. Right, so same idea, right? And then to mark the board, right? If it was valid, then so if valid, we need to replace the current checker with a blank, right? If jumping, remove enemy piece, and then put current player piece on destination, right? Do those things. It's not too bad. So the is game over for checkers is a little trickier as well, right? Is game over means all of one player is gone, or there is no valid move for the current player. That one's going to be really hard to find. Not impossible, but hard to find. So you have to find every piece and see does it have a valid move or not, right? And now not only that, do we have to track that some of our pieces can be kings and go forwards and backwards. Usually pieces only go forwards, but once they are king, then they go forwards and backwards. How do we even track that? So I might need four different pieces notation. I might need white and white king and black king. Because if it's a black king, they can go forwards and backwards. If it's a white king, they can go forwards and backwards. So there's a lot of complexity in a relatively simple game. You can see this starts to get a little trickier, right? Definitely nothing we're handling today, right? Should we try? Let's try it here. So let's go chat GPT. GPT. Let's see if our chatbot can do it. What do you think? Think it can? Okay, C++. And let's user play checkers. It's another player. Do you think it can do it? I bet it can. Let's see. So I'm going to save this off. I'll start a new solution here. Let's do this checkers GPT. Okay, save that one. This was our 2D or 2D arrays. Okay. Come on, chatbot. This doesn't seem like it's going to work. Print board, move a piece from the old X to the new Y, set the board up, get the players. All right, I'm really sad here. This is not very good, chatbot. Chatbot did a bad job here. Hang on, so we got to cite our source, right? This is UMGPT prompt. What do we ask it? That's what we asked here, right? We'll give it a run. There's build errors. Oh, we can't even compile this crappy code. AI is not taking our job yet. This is what I've asked you to do because I honestly don't know. Uh, I don't know if there's any standards at all around how to do this sort of thing, but um, this would give me enough information to know that you asked ChatGPT for something. This is what you asked it. And theoretically, if I plug this into a prompt, I should get back about the same results. Not guaranteed to be the same, which is super interesting, but about the same results. That's all. Yeah, that's what I would like if you're using it. So, wow. Okay, so can I copy this error at line 35? I'm getting this error at line 35. Oh, look at that. It already has line 35. This error. Let's see if I can fix it. I probably didn't ask the right question. Probably needed to ask it to fix the code. Right, and then we can add in our prompts. Oh goodness. Wait, this error. Thinking hard about it. Well, that one's sad. How about we try the Bing AI? Bing, ask Bing chat. There we go. Let's try that same prompt. Let's see if we get a better response here. Right? Because different AIs will do different things, which is sort of interesting. Let's let's play checkers against. Ah, I think my bad prompt screwed it up. I don't want this diet thing. No, or meal plan. No thanks. What? Stop. This one. Please answer this one. All right, okay, this one's using vectors right away. Here we go. Oh, it's giving it a default. There we go. So you can give it a default character. Their little ternary expression, isn't that cute? Oh, wait, they didn't finish the thing. They gave us a to do. Let's see. Can you do the to do? Oh, I had two. It's answering the same prompt again. Yeah, it's got my recent activity here. You can see all my chats in Bing. That's useful to go out on YouTube. All right, let's try this again now. All right, good thing it's nothing terrible. This is recent chat. Okay. All right, is valid move. Here we go. They want. Oh yeah, okay. They use a like a placeholder. They didn't even do it. It's still to dos. All right, if you want the AI to write your code for you, you got to work at it here, right? Remember to replace the placeholders. Please actually write all the code. All the code. I don't want to do anything myself. Maybe we'll ask it nicely. My apologies for the oversight. These things are so funny. Do you have smart devices at home, like your Google or your Amazon or Echo or Siri? Do you say please when you ask it to do things? You do, someone doesn't. Most people don't. My kids don't, and it drives me crazy because I feel like if they're not used to saying please when they ask for things, they're gonna start talking to real people like that, and I'm super afraid. Like my one daughter, she's like, Alexa, lights off. Like, and she's like yelling at it. Like, you don't talk to people like that. Why would you talk to a robot? She's like, because it's a robot. It's like, yeah, but like, this is not how we talk. Like, I don't know. We'll see. Welcome to checkers. Play checkers. Here we go. Wait, a function for play checkers. Still giving me to a complete program. You're still left to do in that version. Please complete them. Trying real hard here. I didn't want a 2 week meal planning option. Why did it give me that? I only get so many chats too. I'm on 5 of 30 now. I'm gonna run out of chats soon because I have to keep asking it. How is that size of four? If you give it one, two, three, four, five, six, seven, eight, 9 characters. It's move size not four. Like that format is not size four, right? It gave me to-dos. It gave me more to-dos. I'm dying. I'm dying. All right. So this one's still thinking. I think we broke it. This was not even a super hard project, and we're having a little bit of trouble here, right? Okay. So the chatbots are one option. The GitHub Copilot is probably a better one made for programming because it's made for programming. I think that part makes sense, right? Um, I don't know. I really so I watched the demo. Did you guys watch the demo that Scott Hanselman and what's his name did, where they built a little two, a little game for their keynote build? I put it in Discord. Oh my goodness, Hanselman build keynote. Let's let's see. Not 2022. This one. Yeah. Oh, Mark. That's who it was. So they spent an hour using GitHub Copilot to build a program basically from scratch. Um, this was super cool. This is definitely worth checking out here. So I think this was only an hour. Yeah, a 1 hour session, and using their GitHub Copilot tool, which Microsoft owns GitHub. Right? So this is Microsoft's AI tool again, but it's made for helping you write code. Now, I don't recommend people learning to code use Copilot because while I love AI tools and I think they've been useful, when you're still learning, it's going to do a lot of things for you that we might not even know what's happening or like, do we, if we know you got it right or wrong? Like that, was the size four here? I don't think that works. Like, and I can look at that and see that I don't think it's going to work. Right? If you're still learning, you're like, oh, sure, the computer told me it must be right, and then nothing works. So you got to be careful with AI tools, right? We looked at that little flow chart of if it's safe to use AI tools or not. That like, do you have the expertise to know if it did it right? It's a really, really, really big if there. Like, uh, so that gets a little dicey there. All right. So our checkers GPT just failed. This one sucked. Why char cannot be assigned type of char? It's a char. Those ones aren't chars? Why did it give me this? Player one array? I don't want an array. I just want a single character here. That's super weird. So I think we can just take this out. I think this was the problem here. Just say equals X. And we can say equals O. I think that might take care of our problems. Oh, no, it didn't. Oh, there it did. It took care of the problems. So that was nice. So again, it does weird stuff, right? So we'll get there. But Copilot's really cool. So this demo is super awesome. I'll put the link in Discord again. Definitely well worth an hour to spend and look at what they did to build this out here. And I think using Copilot for engineers who know what they're doing. So Hanselman and Mark have been doing this for a long time. They got a lot of experience. They can use the tool to make them faster. It's not just somebody off the street uses AI tools and builds applications. Um, maybe we'll get there someday. I don't think so until they get way, 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 way better. Because you have to know what's happening. You have to know what we're doing. So we'll see. Maybe the YouTube videos about people building apps will prove me wrong. But all right, we good? What else we going to talk about? We got a little bit of time to work on the project, our Ticketmaster project. Again, you have to know how you're reading it to write it, or you have to know how you're writing it to read it. That's the most important piece there, right? So if you just do line, so you have 3 lines for every ticket, you can read 3 lines back out, throw them into your vectors. We're good to go. So index of 0 for all 3 vectors will be the same ticket. Index of 3 for all 3 vectors will be the data for all the same tickets. That's sort of, right? They just kind of go in parallel because we haven't got there yet to the better stuff. Next chapter, we'll get to the better stuff with objects and classes. and we'll wrap up with pointers, and then we'll do our final project. So we're about in the home stretch, right? We've got object and classes. We'll talk about the final project using objects and classes and vectors and streams and all, all sorts. We don't get to forget anything here, right? And then we're off for break. We come back for pointers. We got a week for work time, and then we present on the 11th, right? We are about a month away from the end of the semester. It's crazy. Next week. Yep. Yeah. So project three is due on Monday, right? So we can go over the final project on Monday. Um, objects and classes. It'll take. There's a lot to objects and classes, which is great. They're super cool. Yeah. Yeah. The final project will use objects and classes and everything else here. Um, probably will use. Uh, I gotta think about it more. I don't know if we'll use pointers or not. Uh, I think you can do it without. It'll be useful if you do. I don't remember right now off the top of my head. I'll spend a little more time on it. All right. So it's been fun. Um, yeah. See you Monday for new stuff.